But yeah, welcome everyone to the forum of the Wednesday, February 7th. We are chatting with Vladimir Baulin, who will be talking to us about a project he's working on related to dPID, AI, and data management, which is like a lot of buzzwords that are very important. So I'm excited to hear more.
Yes, thank you for introduction. I'm now in Spain, close to Barcelona, in the city of Tarragona, University of Tarragona, and I will tell you maybe I start with the introduction, so why we are coming to this topic, and then I will go to maybe in more detail how it can be connected in what you are doing. So if you allow me just to go briefly, because this is kind of a standard thing. So that's, as we know, that science vision is always a dream, scientific discovery and making groundbreaking discoveries and exploring mysteries. And in fact, it doesn't work. And it's all these things what we were discussing about reproducibility crisis, or publishing, hierarchical management, and uneven distribution of funds. And this is maybe, yes, as we will know everything. So this creates all this problem with publishing. Predatory journal perish and or publish or perish. So this is what we know. And that's coming from not from the publishing part. And this is what I'm trying also to make the message that the problem is in this unnatural aspects, that instead of evaluating science or evaluating impact of the science, there is a focus on big groups for big groups, and then money is distributed in this hierarchical manner. So then what you have is in basically the competition, and the competition is ruining the science, because you are focusing on people and the leadership. And then this hinders sharing cooperation, which is the basis of the science. And then not every it is not possible that everyone is a leader, and then this created big problems. And there is also a book of Margaret Hefferman, A Bigger Price, about this this super chickens, and this kind of one of the things quite interesting to have in mind. And then basically what it gives is a hierarchical management structure. And this is basically, this is the problem, not even the publishing is just a consequence. Then this unnatural structure, it is coming to this pyramid structure, where only the professor, which is on the top, is visible, and he received the funds, grants, and invitations, and all the things. So this is, I think, a problem. And the main problem that you cannot be outside of the system, because if you don't fit into this pyramid, you cannot do anything. So for example, you cannot build something, even because you will be immediately run out of money, and you are out of the infrastructure, so does not exist. And there is no alternatives. And this is the main problem, because if you cannot work, and all the rest is already irrelevant. And then this is already consequences, like research of the retraction watch and all these things, what is already known. This is already consequences. And the publishing is also consequence, because this is a consequence of this decentralized, centralized and the pyramid structure. But this, I think, it's just introduction. But then, of course, that what you know, that how to solve it, and this is to focus. And so instead of evaluation of the scientists, it should be an evaluation of the impact of research, not CVs, but research. And instead of these big groups, static research groups, it should be dynamic groups, which should be constructed by themselves. And of course, this retrospective funding is one of the model, and it is that you know that it is good, but maybe there are other ways. And this is already, solutions are quite here. So for example, technology is here. This is Web3, and what it is already standard things. I don't need to repeat. And okay, there are tools like this Artisan and Hypersets, of course, they are not optimized and not developed for science, but it is not a problem because basically it can be used, and all these things, it can be done. And then I will go to my topic. So this is introduction, but and it's probably all these problems and they are discussed a lot. And how we approach it and what can be done, and then what we try to do with this work, what I was trying to build something related on the augmented research, which can be connected to dPID, and also it is about interconnection between data sets and research items. So if we think that instead of evaluating researchers, we can evaluate and based on research items, then we can also certify them and put it on the chain, and then they can be available for machines to search. So, for example, one of these technologies is AI, that you can use this technology to connect different research, and you can. This is basically search. So you have a publication search. You can search for people, and you can connect them dynamically, and you can connect into. And you can classify, logical connect into dynamic network of research items. And of course, it is this, I think, dynamic network of those research items. It may be interesting and maybe new property that arrives from this certification through the blockchain and all these things that you can connect and reconnect. And basically, of course, you can also do dynamic review and validation also on the chain. So this, I think, we will not stop too much because this is also connected. And I will show you a practical example. So we start with the research ecosystem, which is based on agriculture. And this is why we want to do it on agriculture, because first of all, you can show that everyone can be a researcher, because if you trust the data, and it doesn't matter it's come from a big professor or just a farmer. And on the other side, it is much easier to advance, and then you can work with this. You can install anything and you can work much easier with this kind of people. And in addition, if you build this something for this environment, it just copy paste to any other research field. And I will show that it is basically very compatible with all these ideas of decentralization. And we created a project, Vinq, which is based on data. So it's instead of connecting people, it's a kind of a network of for data. And here, what we have is we can use this data which is collected in the fields to amplify collective intelligence. And we can do this is connection with a persistent identifier. So this is, I like this picture, so that you see that this idea of nested containers, and this can be applied to any sort of data, because if you have a container, then if you have a project, and project can be a title and different insets inside inside the container. And if this project finish, then and abandoned by the authors, then this data is still available, and you can create another project. It means it is another container, and you can restructure it, and you can again build on this data which is already available. So that's why I think this persistent identifiers, the power will be in this, that to connect different data. But the question will be, so this is what we are trying to do. So this is our project, and AI is connecting on one side sensors, metadata, and historical records with the data which is verifiable. For example, the production, we can sensors data, we can connect with the data which we can trust. And I will show you example how it works and how it can be constructed. So first of all, this is also different people has different interests, different people. So we have scientists and farmers and service providers, and all of them have their own dashboard and also their own structure of the data, but the basis of this data, and it is the same SQL table, which can be just restructured in a different way. And here we go to this concept of participative research, when this data is connecting scientists, farmers, and service providers. And it also can be demonstrated for consumers and administration. So this is very similar to tracking, and then you can also prepare containers for administration, and there they will see a global picture, for example, what is happening in one region, and consumers will be also seeing what is happening and what exactly is doing. What my message that this is already technology is there, and we just need to connect it and to build on top of all these things which is already available. And so this is data-centric knowledge sharing. So this is Vinq, and then instead of so we instead of connecting people, we connect data, and then data is basically the source of this information. So then I like this picture because this also shows how it can be integrated. So you have metadata, you have data and operations. And this is basically the same. So this, if you see, we have a dashboard with a lot of types of data in our dashboard. It is SQL, and for each of the type of the user, or even for each of the user, we create a dashboard, and the same data, it can be represented in a different way. For example, farmer is interested in what is happening in his field, all the data related to his field, and how it is different from the neighbors, if he's doing something different or if he's doing the same. And for researcher, he is not interested in one field. He wants to see the comparison of the data sets, very flexible for his research on many data points. And then each farmer is just a data point. And what farmer is doing is just exploring parameter set. So this is a point in the parameter space, and they're just exploring. So that's why for researcher, it's a completely different presentation of the same data. Then for service providers, they also need to see what is the interest, who is doing what, and what is the needs, and administration as well. They want to see what if their practices, what they impose, are working or not in a global scale. So there is a lot of way, but basically it's a data, and this data can be verifiable. And this is the idea. We'll go quickly on how it is structured. So we have text, maps, and different representations. So weather, maps, management, soil analysis, color. So we have sensors data, and it's can be analyzed directly in the dashboard, because this data coming from the sensor, you can have also this Python scripts and the Jupyter notebooks and working on this. Then next step, we're also connecting with models, so putting several models to analyze this data. So this is just to show. And what we also have the practices, because each farmer can report what he is doing in the field, and we can also have all the practices for many years, what is going on. And this is also data, which is very important. We have also a lab analysis, for example, this bacteria, fungi, and we see this is again another type of data, and it also go there. And this is trustable, so we can say this is really true, and we can certify this data, and based on this data, it is the source of the decisions that can be taken. And also these maps, we can have different maps, 3D maps as well. So this is also can we take photos of plants and biodiversity, some different analysis of the drones and comparison between different things, different fields. We can see how it is distributed, the colors, and different sensors and other the types we can. This all type of analysis can be done. So what I wanted to show, and that can be how it can be related to your work, is that as you see that it is based on those small pieces, which is those identities, which are verifiable and reliable. And this is not as it is done now in the science that we trust to result because of human reputation or because of the journal reputation. Because we think that if something is published in a good journal, that means, yeah, it had good reviews. But instead of this, we want to go to machine check. And the machine check, what does it mean? That we want to be sure that if we put something in the database and we certify it, that it is reliable and verifiable. And in fact, for each of those pieces, it is already done, because if we take a microscope, we know from the experts what if you have what is the type of the microscope, what is the name of this microscope, what are the settings and parameters you need to report as a metadata in order to this result, it will be reproducible. For each of those this material in method section, of course, now it is just written and it is very difficult to prove. But if you do it through machine will check. No, you need to put all the settings, and what this setting should be in this form. And for each microscope, in fact, it is already done. It is known that you cannot avoid those parameters, settings, and names. So if this is done, and can be done by a machine, then you can trust it. And after this, you forget how it was done, what is microscope. You say, this is trustable result. The same with the sensors. Of course, the sensors, they are very different. They can be even faulty sensors, they use this, but it's also solved because which type of sensors and can you trust it, how it should be calibrated, and there is also LoRa trust, and this is also you put it on the blockchain. There is also a method how to verify that the data of the sensor is correct. Then it's also this data is a dPID, so you can put it on and register it, and then you can trust it. The satellites as well, that satellites are already big companies, and they care about this data, and they can also say what is the limitations and can you trust it or not. For example, if the surface temperature measured by the satellite, what are the limitations to trust it? And this is just the metadata. You put it in the file, and then if you want, you have those individual pieces. It's like a Lego that you can then dynamically link. Either you can do a publication out of this and using all those data, but what is interesting here, if you can dynamically using algorithms to create your own data sets from different type of those dPIDs, and which are trustable, and you can say, I'm not the expert in this field, but I know that people are using the correct procedures. They use these microscopes, and then the data is trustable. So then you can create it from completely different field. You can create those data sets, and they can be proactively created. You don't need to store everything on your device or your database, but you can create these data sets for your research. And then you can use machine search. You can use even this LLM to find those dPIDs and how to connect them and to select them. This is also quite a piece of work. This piece is very well done. Then if you do it this proactively creating these data sets, then you can analyze it, and then you can write papers, you can do analytical theories, you can do computer simulations with them, you can do your own research, and you can use, basically here it is important that you can use data of other projects, and you can repurpose other projects which are already finished, abandoned or whatever, but you can use it because this is according to your needs, they are trustable. So here you have a reproducibility part, it can be covered, and you also you can trust to data, and you can augment research. This augmentation of research, it means that you can, if for your project you don't need to start with data collection or to do it again, because you can use data from other projects which may be focused on a different research topic, but you can use it for your research. And then
quick question before we move on. There's a couple of questions coming into chat. Chris, do you want to unmute and talk about those before we jump on?
Okay, maybe I will check.
Actually, I think I'm just keeping a list of questions I'd like to ask at the end, I think, because I think we're going to be bouncing back in a couple of different places. So perhaps let's just continue with the presentation.
Okay.
Cool.
Maybe I'm already very close to the end because I just show you a practical example, and then we go to questions. So you see how we use it, and this is just example how we use it. So we have an actual state, and this is basically one point in the parameter space. We have, for example, we go to farmer and say, what is your state of the soil today? And then we have sensor data, weather data, lab test, and we have also data about production diseases. They are all can be verified because we trust it and we can verify it. And this is actual state, and this is just a vector in the parameter space. Yes, and with the coordinates. Those are coordinates, and we have a parameter space. And then we cannot say anything about, we cannot say anything to farmers. So is it good or bad? We cannot compare. We cannot do anything because it's just one point in the parameter space. We don't know how the system evolved and what happened to it. Because if you need to know all the history, maybe all these management practices, treatments and products applied for 5 years before, how it arrived. And that's why we have a historical data, and this is a practices, treatments, and products, and this is a big list of when, for example, it does something, then we can report, and then this is another source of data to see the dynamics and to see what happened to it. And then this is used, this is historical data is used to create a baselines and the reference states, because we should know what is the normal and what is abnormal, because without these baselines, we cannot say it. And then we can use this historical data for machine learning. So this is basically, you can use a correlation matrix to see which parameters are important. You can see also machine learning, and also you can use literature to know what is wrong and what is good practice, and then you can feedback first to a farmer, and you see, yes, we can verify your practices and treatments and say if it is good or not, exactly for you, with personalization for your climate in your position. And on the other side, we see that each farmer can be considered as a point in the parameter space, and what is doing in the field is just exploring parameter space. And from this exploration of parameter space, we can train AI and also get a feedback loop. So we see the real effects and how the practices affect this. And then this loop is allow us to build a model to evaluate the practices. And what is was done, this what we do, that this we create automatic report, and then we can see that putting all these practices, and then we see what it was done and what time, and then also embedding all the literature related to this field. And then we can say if this practices was good or not, and then if this was adequate or not adequate. And of course, with more data, not only from this farm, but for all farmers, we can improve this accuracy of those predictions. So this basically how we do it. And I think this all this DeSci can bring back creativity to science. And if we do it in this interactive way and connecting science, then we can do things together. So that's my talk, and I'm ready now to go to yes, I'm ready to take this questions.
Sweet.
Yes.
Yeah, thank you, Vladimir. Much appreciated. I mean, it's a very meaningful project. You're essentially attempting to create a virtuous data collection and analysis loop to improve the livelihood, the yield of farmer, reduce the incidence of devastating outbreaks and so on and so forth, right? So I had like a couple of questions around how big is this data set? So I'm just trying to wrap my head around it. So it sounds that there exists like a data set in a tabular form. It's an SQL model essentially, and it's a data set that you are curating actively, right? Where you are like or people within that organization are adding to it. And I'm kind of curious to understand more around the size of the data set. Who actually puts more data in the data set? Like, what's that process like?
Yes, at the moment, there are different sources of data. For example, the sources from APIs, from weather stations, and from also Copernicus. This is a very good API with you can access this data and sensors. It can be done. Additionally, you can put also laboratory tests that it is available, and you just put it more or less manually. And then you also have a book of operations. These practices are registered in the book of operations, and this is data sets which are quite big, and they are managed by companies, but the private, who is the owner, is the farmer is the owner of this data, because he is forced to report now it's in electronic form all the practices and treatments and products applied. So that's why this is historical data. What we have, for some of them is about 100 for 10 years, and then in cooperatives they can have hundreds of them. So they can be hundreds of farmers, and there's different fields, and for each field it is its own data set. This is kind of how this organized.
Okay, very interesting. I'm quite fascinated because there's also a community aspect to data ownership from the farmer's perspective, right? So
and this is why we started with farmers, because you see it is a very abstract way, because it doesn't matter if it is farmer or you work with the medical data, because it's exactly the same. But with the medical data, it will be much more difficult to do anything, because with ethical approval, and here it is also there is a privacy issues, but it is much easier to start. This is
Yes. No, this is a great use case because of the inherent openness of the data, in the sense that it doesn't have any regulatory restrictions, right?
There are some restrictions, but much lower than, for example, all the sensor data, Copernicus data, weather stations, they are completely open. You can do what you want.
What's the rate of update to your database? How frequently do you update it?
So, for example, for sensors, it is quite maybe it depends on the sensor, but it is it's quite fast, and then you also don't need analyze it every time. So it can be every day you have all this bunch of the data. And for the weather as well, you know, that depends on this, and then you can call this weather when it is necessary, so that you can collect this data quite flexibly. So we don't need to ask it every time. And especially for those fields, you don't need very often update of the data, because those changes are very, very slow.
So perhaps would we be talking? So just to give you some context on why I'm asking all these questions, I'm really fascinated by the way you're thinking of using dPIDs and the underlying protocol for that, right? And I'm asking these questions so that we understand the range of requirements of people that have these types of data sets, right? And out of these requirements, understanding the update frequency, the total size of the data, the way that data is represented, all of those are very valuable for us as protocol developers and designers, so that we can create the perfect container for you, right?
Yes. And that's what it would be nice to have different containers for the same data. You have different containers and restructure it. This is how we do it, because you can you have these farmers in different climatic zones, some of them in the mountains, some of them close to the sea, and you have them different soil types and different, and then you can sort. For example, I need farmers which are distributed in different climate, and they are using the same product. What is the consequences? And then we say, oh, no, I want something that's only winter and in cold conditions in mountains. I sort farmers for this effect. So then you need a container for this. And then you say, okay, I have this data and they are all coming from this requirement. And this is how it is done. So the update is not, you don't need a lot of update. You can do it even once a week. It is fine. And also you operate basically with averages, because you don't need every minute temperature of the soil, or you don't, because you just need, if it is a hot or not, or you need this average temperature. That's why it is not necessary to update a lot. This is also nice about this.
Do you have a paper or a document artifact describing that data set that says there's this wonderful data set that's extremely useful for all of these groups of stakeholders, and this is, you know, the document accompanying the release of this data set for the public?
So we are moving through this, because this is our step to write it as a scientific publication, and then we can describe this all this, how this data is stored and how it can be. And this is now in process, right? We are starting doing now, and to write it as a text. It is still not finished.
I see. Because I could see like the ideal artifact in terms of a dPID container would be something like, you know, there's a document artifact, right? A scientific publication that explains to the world what is this data about. There's high quality metadata around describing that data in sufficient amount of granularity so that it can be easy to reuse, right?
Yes.
And then there's the data object itself, what in your case seems to be a relational database, right? So it's it's SQL object, right? Essentially.
SQL object, and it's a relational, yes. And it's we are trying to to write it, and in terms of augmented research, because
how big is that SQL database?
This is what we have, maybe not big, because it is, and what is nice that you can rescale it. For example, we don't store a big database. This is a database for specific publication. So we did one publication, and it was completely different contents. It's about sea data. So we analyze on the ground of the sea, but it's the database exactly the same. And it was a data of 1 year. So we analyzed 1 year of Copernicus, and others. And this paper, which we are now ready to submit. And then if we have another one, we just restructure it, and that we can store in a different way. You see, because it's most of this data from API access, then we don't need to store it. So that's why, how big is this database? It can be big, so but we use superset.
Yeah, I understand. You're using a condensed representation, a subset of that, and at different points.
Yes.
Yeah, interesting. I mean, we're really interested in ways we can make data maximally useful for other scientists and other stakeholders.
Yeah.
I think that's really something that's very important for us to in the way we're designing this. In that case, how do you see, you as a researcher working and also knowing the farmers and other stakeholders that interact with that type of data? What do you see as the ideal interaction pattern with this, right? So just to put my question within the context of your presentation, you showed in some couple of slides, you showed a number of like web apps that would go in the data and represent the data dynamically, right? That's like a model of interaction on that data. But yeah, I'm curious to think how to make the data the most useful in a way that others will reuse it.
Yes, so if we talk about farmers, they want to have predictions. For example, we know that it will be a hot summer, so what they should do in winter, for example, or something like this. If it is already plants under stress, so what do you do? And the practices, what they use, if they are good or not. So this kind of things, how to manage disease. So, for example, there is a disease, and then they know it's every year it appears, and this management is adequate or not, something like this. They just need this guidance.
This web app you showed us with the predictive dashboard, is this based on the subset of the data you have created, which is then provided as the data, or is it based on the live APIs from Copernicus and the other data sources?
So this database there is some of this is statics, because there's some data is included, and some of them are collected from APIs. Yes.
So the Vinq in that context. So okay. So I understand. So there's essentially both the subset of the data you create,
yes,
and also some other APIs that are queried.
Exactly. Yes.
Allow
And
for
this is exactly this is augmented research, that you can repurpose other data and then you augment your data set of this field with the data, and you can have all the neighbors, they are contributing to it, and then you have much more information, because they can have different practices, and then if they use different practices but they have in the same climate zone, then they have a completely different result, and then you can compare who does the best. So this kind of things, it can be interesting, and it is very flexible, so you can restructure it for any research topic.
Is this question also shared with Ellie? So the people that can edit the content of this data on this web app, who can change the content? Like I see edit dashboard up there.
Yeah, it is either it is automatically done or through API, or it is this lab it is putting manually. So this at the moment you put manually the results of the soil analysis. You put results.
This is your lab or a lab you're affiliated with? What's the?
Yes, it's our project. Yes.
Perfect. Okay. So now I got like all my I's are dotted and I have a good understanding.
Okay. Yes, and this is exactly the same database we use for other topics, like the investigation of the sea and other things. Yes. Mm-hmm.
Yeah, super interesting. Yeah, I'll leave the floor to others to interact here a little bit.
Yeah, one thing I wanted to jump in, kind of related to the researchers. You were mentioning specifically, oh, like even farmers can be researchers. So does that mean that you're having, like, one of the benefits of this is that farmers can input their work that they're doing or maybe their observations, and then that is also included in this database, and some of the part of
Yeah.
the AI is like translating their data into something
Yes.
that's also machine
Yes.
readable?
So what we have is the historical data. It's coming from the farmer, and then it's what he does, practices, treatments, and product supply. So this is input from the farmers, and
Okay.
they see the result. For example, then this is analysis because we have also all the publications that is with the instructions and also requirements. For example, you cannot use this product, or you cannot do this when it is too hot, or something like this. And this will also include, and those documents also processed as kind of, this is embedding and those language models. And then this data can be transformed to the farmer in way of instructions. This is instructions and also evaluation of those practices.
Yeah, very cool. I mean, I think this is very useful science, actually. I'm
Yeah.
very much in favor of improving the landscape around
Yes,
that
exactly.
space.
And that's, you can even evaluate, because here it is important that you evaluate, not this is AI is trained on this data, but you train not on voting, also on people saying some things, but it is trained on the real data, because we see if biodiversity, we can measure biodiversity, we can measure how many bacteria, fungi, birds, and everything. It's possible to measure. And we will see this is improving biodiversity, and this is, in this particular point, it is improving. We cannot say it why, but because then why you need all this history and all the thing related to neighbors and all know everything around. But you can certify this is improving or decreasing, and then globally you can see if there is improving or not. So this is a real measure of this climate impact. For example, if all farmers will not use glyphosate, or this will not kill the environment with this pesticide, then it will be a global change in the environment, and you can measure it.
Yeah, no, and this is you're saying also that this is a national program in Spain that requires, that mandates that farmers report that data.
Yes, there is this. It's not only in Spain, in Europe. It's in Italy. So we have also farmers in Italy, Croatia, and Portugal, and we can. And this everywhere now. This is historical data. They need to report, and this is very useful data, because it just sensor data and what is happening, it is not that useful because you cannot interpret it because you don't know what is happening. But with this data complement together, you have those reference states and baselines, and then you see what is it how it performs with respect to previous data. This is the key of this work, and then you can really train AI, but on real data. So you see, this is certified, and that's why dPID, it can be used to certify it.
Yeah, no, there's real value in like applying machine learning algorithms here, or even simple predictive models, right?
It doesn't need to have a very simple. We have even forests, random forests, on something very simple.
Exactly.
It works because those relations are really simple. Because if the plant is growing, it's exponential growth, and then you only have two parameters. So this is
highly tractable. So the way I'm thinking about this, like just as an intuition here, so correct me if I'm wrong. So you're creating a textual artifact, a publication describing, the meaning of that data set and what is hoped to achieve with this approach, right?
Yeah.
There's also a certain database of a certain size that is updated, let's say on a monthly basis or on a rolling basis, right?
That is enough.
There's also an external web app that your group have built out, to provide a dashboard interface to
Yes.
that data, right?
Yes, exactly.
So
Yes.
these are the three main artifacts around that research
Yes.
project.
Yes.
Okay. So yeah, so that's actually very interesting for us because we could see how we could actually create like a container around that would allow you to have, you know, when you talk about machine verifiability, right? At some point of your point, you talk about this. I think that so in that case, the way we think about that is that any form of verification, be it human-based verification or AI-based certification or whatever-based certification, right? At the end, there's an agent that signs a digital object with a key and says that came from me, right?
Yes, exactly.
That
Yes.
agent can be human, can be digital, can be whatever,
Yes,
right?
yes.
But
But
the
not human
key,
reputation, you know.
exactly, right?
Because it's a big professor, and that's why I trust him. But it's yes,
Yeah,
but it could be any it's human, machine, or anything like this. It's
anything, right? So you could imagine then that you would have your research artifacts as a container that contains that data set, the the human readable instructions, right, which is the publication in a sense, it's metadata on top, right? And the web interface, right? This outgoing link that leads to a dashboard where that data can be dynamically evaluated and queried, right?
Yes.
And that object, that digital object, that dPID, right? That container, dPID is a container that provides PIDs for every individual object, right? We can then, for example, go in the database and have every table or every keys, right, having different PIDs, for instance, right? We can think about the level of granularities in the resolution schema and the addressability of the object.
Yes,
Now,
yes.
now there's that digital object, and then there's an attestation, right? There's someone who comes in and says, this is valid data, right? And that entity, you know, can have a reputation, right? For example, it's a trustworthy provenance from a research group in which the attester controls the key to say that this data has, you know, is legitimate data, right?
Exactly. Yes.
And so that's a little bit the way I see that representation. And then you think of that research object as a way for other scientists, farmers, people within the community, the broader community of data users, would use that research object as a support for communication, right? It's like, how do I reuse this? You know, how does this work? Or how do I cite that, right? How do I, there's essentially a conversation that happens around with the creator of the research object and the community that aims to reuse that object, right?
Yeah. And this reuses, and I think this is dynamically ad hoc access to those dPID, and then already trustable because you know this is true, and then you can build on this. Even the project is finished, and that's what in our actual work we were trying to get many data sets, and it seems that now it is not appreciated to have data sets because everyone is interested to have a publication.
I know. This is the big problem. We feel the
and
pain.
then these data sets, either they are missing or they are put in somewhere and you cannot access it. This is a big problem.
Yeah. This is the problem of the value that we assign to these different artifacts, right? It's a huge problem. Like we only value publications and all the rest we don't care about. Whereas in your case, the thing that creates the value is the data object, right? And it's tremendous value for like the stakeholder ecosystem around that data object.
Yes, and then this it can be built on top of this. You can build a lot of things because you can measure it because this is a real measure of what is going on, and this you can measure effectiveness of the practices. You can measure biodiversity in global scale. You can see a lot of things, and you can have with the certification, real interest certification.
How many collaborators work with you on this project?
This is very decentralized, and we have not so we have a company, so this company is also quite young, and then collaborators we have quite a lot. You see there's farmers, and it depends on we can build it on depending on what we want to do, because we are now focusing on building this dashboard and building the platform before expanding. So the first idea is to show it in locally in our region with a few farmers, but then to expand it to other parts. It's like you see, this is open research. It is an open lab basically. So you convert fields into data sets. You see, this is you have. And even if someone want to test a compost or some method, or then you can easily come and say, okay, I want to try in those climatic zones 100 data points. And then you say, okay, we ask farmers, you say, do you want to participate? This is conditions, and then you put your compost and then on your test field and they see what will happen. And then you can do this. Yes, you can trade. And then you collect automatically trustable data, and you participate in research project.
Yeah, and you can have also, I can see commercial applications here, right? They're very obvious actually. So, whether in terms of yield selection, crop selection, policies for farmers to apply, the type of products they buy,
yes.
insurance, right? Crop insurance.
And insurance and also effects of the climate change. And you see this, so all this, what happens in reality, you can compare with 10 years ago, what is happening now. So this there is a potential, yes.
Yeah, very interesting. I mean, we'd love to see how we can support that. So as you move towards the finalizing these artifacts or having them in a more advanced stage, and once you feel comfortable that it's all more or less in place, we'd love to help you see how you can create that research object, right? So having the dPIDs, making it trustable, having the attestations around it, and all of it. I think it would be a really nice example.
Yes, and this would be, I think, for those objects, the dPID, it's a good example. It's how it should be done in reality, and also for publications. So, because these materials and methods is a key. If you results are true or not, you need to see if this you have all this data included, because otherwise you don't know what to do with it. And then if it will be a collection of those dPID, so you see this, and then already conclusions, it can be done already. This is analysis is already on top of it. But if you don't have these basic attestations of the quality, then you cannot make conclusions. And it doesn't matter where you publish. I think this is always missing, and you cannot be an expert. If you are a reviewer, you cannot be expert in all fields. And then you see, for example, biological papers. It is very good as biologists, but their use of statistics, of how they use that physical concept, because they are not experts, maybe not correct, but what they are doing then and submitting to biological journal, and the reviewer also from biology, and they don't see it, and then you have publications.
Yeah, I agree. Yeah, this is because we have a one-to-one mapping, right, between a journal, a community, and a publication, right? It's a single axis. There's no paper gets peer reviewed twice if it's accepted the first time, right?
Yes.
So
and it is not even polite to criticize something that you already published. So
exactly, it's like considered. It's considered like unacceptable. Yeah, I know. I mean, we feel very dearly the points you bring up here, and we'd love to help.
Okay,
so as
that's
you advance, let us know. Keep in contact, and also happy to take questions from you if you have any questions about how we.
Yeah, that's why I'm working on this, finalizing the system, and after this we will be open to other, to talk to people and to try to get funding, because this is also quite important.
Yeah, that's something we also would like to help with, right? So we're working, establishing prizes, alternative models of funding. I think especially in the case of your research, there's a case for commercialization, right? So that also can help with attracting funding, because there's real world impact that's, very manifest potentially.
Yes,
So
yes. Especially for those climate projects, they are not really evaluated because it's like on Twitter, how many times it was cited on Twitter, on how big is the community, but it is not a real evaluation. Yes.
yep. How many scientists do you think within your network or the people within that broader community of agricultural data-driven research, how many of those people do you think would reuse such a data set if you have to, if you'd guess?
Yes, I think this is what we try to build now. To on top of this, to have access through Python code, and then we will explore how many of them, because this is very rare. Usually, this research is based on the very small set like of data. And what I try to say, because many research done on data collection, and then this data collection is in 1 year. It doesn't mean anything because you have a climate change, and the climate effects its impact more than for example, if you put some grass or this cover crops, and this effect will be even less than a global change of the climate. And then your data is not valid. But if you do it in this distributed way, and taking into account all the previous history and all the management style, you will have much better results, and you understand much better what is going on. You see, this what it is not easy to transfer, because all this research is still in this. You need to go and to set up from the scratch data collection and then analyze results. And this is different. This is not easy to approach.
Yeah, no. I mean, I absolutely empathize with the problems and challenges here. The scope of your data set is Spain, or is it a specific region in Spain? I mean, how do you
at
think
the moment
about
we have this region Catalonia, so this is our region which is limited because we want to demonstrate that it is used, and after this we can expand it.
Very cool. Yeah, really interesting. I could also see a lot of people, in a very decentralized way could be interested in contributing to such a project.
Yes, and
Yeah.
this soon we will have, and it will be necessary to have people, yes, to support with programming, with also to setting up, because we are a bit slow because of this lack of resources.
Yeah, no, I mean, it's a very worthwhile thing to do. And I could imagine, the way we're thinking about it is that there's this research object, right, which is anchored within this PID container, contains all of these PIDs, methods of operation, metadata, human artifacts, artifacts from machines, et cetera, right? But it's also like a place for community collaboration, right? It's a place where communities can come in and actually attest to attributes of research, right? Someone could say, well, this has commercializability potential, right?
Yes,
Someone else could come and say, oh, there's an open data, right? It abides to the open data policy of our society, right? Our scientific society that has certain standards, right?
Yes.
Or you can imagine a group that comes in and says, oh, the data is fair. It's appropriately described with metadata that makes it machine actionable, right?
Yes.
The appropriate types of API that it can be pulled in and out automatically, programmatically by machine agent, right?
Yes, yes.
So,
and what you are talking about, this is called a living lab, and we applied for project as a living lab, because then we can, it's a perfect place to even to discuss this data, not only to collect, but from different experts. And then, yes, it's difficult to get this funding. So now we're trying again this living lab, maybe on a small scale. We tried a big project with 5 living labs. Now we tried a small one for 1. So it's, but this also has a sense, because then people can come to discuss, and this is community around this. But here we want to make it that it is based on data, this collaboration on data, not just what they think, not opinions, not this, but it's on data. Yes.
Yep. No, fantastic. I'm very curious how you see the cooperation model around a living lab. How do you see that? How do you see a community? How do you imagine a community that forms around your project and that data set? How do you?
So but this is a bit also different because I can design a very nice one because I was also coordinating one European project, and you can design what and you think a very visionary but there is also requirement from the funding agency, and basically you structure it according to some politicians because they decide how it should be in Brussels, and then you cannot even step left and right because it's already defined how they see it, and they see it as a social science. Basically they see that it's a place they come and talk to each other, and and there is no place for data. And then if you want, yeah, I can do better, but it doesn't fit, this is a problem.
Yep.
And we face these problems because you can see how it's like that's what I was showing in previous slides, that it is very important that it should be alternative path for funding, because I know many researchers, they want to go outside, but you cannot because there is nothing. So you will be completely out of the system because you are relying on those grants, and those grants already decide how
Yeah. No, it's insane. Like I really hear
how
the
you will
pain, right?
publish, and you there is a funds already for open access, so you have no choice. You have to pay to editors and all these things. That's it, all this already defined, and then you can either you accept or not, and if you're not, you're out. This is a big problem.
Yeah. The coordination space, right? The tools by which communities can coordinate and form is very.
That's why we thought about these data, but it doesn't fit in what the call is about, and this is not on data and social science, and they need to communicate more to have also administration there. So this again.
How many people do you know, like within your network, that like are also interested in doing data projects, right?
Yes,
Is
so
this something
we have, and we're writing this project. So I was coordinating the project, what we were submitting, and it was around 100 people. Those are actively involved in some way. So because we have several countries, then they people bring other people, so they work with someone. So and this kind of become big.
Yeah, because that's important, right? There's power and legitimacy in science by coming in with a community, right? That's
but
really...
then you need to come with a real project, because if you don't have funds, then you cannot talk to people. We are busy.
Exactly. Yeah, thank you so much for sharing all of this with us today. Much appreciated. We'd love to keep in touch and see how we can help you on every level, right? So technology, funding, different things, where we can help. And so we are very, very passionate about these types of projects. And
okay, thank you. I see if there is any other question. No, it's in this room. Okay, no, it looks not.
I don't think so. I will have a follow-up email with you. There's a couple of people actually trying to build some things around geospatial data right now that I think you might be very valuably connected to, if that makes sense. But otherwise,
Yes.
yeah.
Yes. Okay. Yes. Yes. So and it's what I wanted to show, that it is very flexible and can be applied to any fields, because it's on a high level. It's kind of, you can do such type of research practically with any type of data. And this is very interesting because you go out of these borders of the departments and research inside, then you can expand. Yes.
Yeah, definitely.
I'm very eager to see where this leads.
For sure.
This was, yeah, thank you so much. This was really fascinating. I haven't said or asked anything, but this was really, really good presentation.
Okay, thank you.
Cool. Well, thank you so much for your presentation. And I'll keep in touch.
Thank you. Bye, everyone. See you next week.
Bye.
Bye.